Hi, everybody. Sorry, I just got up from another meeting. I try to get a drink of water. Okay, so let's talk about the lab for today. If you get a minute, go ahead and check out your Canvas. And then hold on one second. I'm going to get on Rappel real quick. Okay, so today we are going to work with graph in C++. I previously showed you that there is GraphViz, and I posted some materials online in case you're interested in using GraphViz. So I added the GraphViz page here, and I use it in my Python class for networking. So the recorded session is the lab that they did, but it walks you through on how to use GraphViz in case you're interested. I will post the Zoom recording for today's session on the following page, but your lab is located here. And let me get to my folder real quick. And we'll talk about the lab now, okay? Actually, let's do this real quick. Okay. So when you look at this, the first part of it is illustrating to you. It shows you, yeah, that's kind of tiny, right? Give me 1 second. Let me move this real quick. Okay. So as you look at this, you would find that this is just the illustration. That's what we would see in a graph from our exercise in the assignment. Okay. Um, and with that, you would have the nodes, or what we call vertices in this class. We have 0, 1, 2, 3, 4, 5. I'm sorry, up to 4. Okay. And so this is an undirected graph. And what we want to do is we want to first identify your edges and your vertices, like what we've done before. So with your vertices, you simply just list. We have 0, 1, 2, 3, and 4. Okay. And then you have the edge. So we have adjacency from 0 to 1, 1 to 4. So we can list those. Okay. So we would have 0 to 1. Okay. And you would list these, and then 1 to 4, or 0 to 4. Let's do that one first. And then we would have 1 to 4, 1 to 2, 1 to 3. So we would do 1, 2, okay, 1, 2, 3, just like what we did in the assignment. 1 to 4, and 1 to 0. And then next we can display the edge for 2. So we have 2, 1, 2, 3, and we now move over to 3. So we have 3 has 2 degrees. So 3 has 3, 1, and 3, 4. Okay. And then we would then move to 4, which has 3 degrees. So we would have 4. And then we can do for 0. Okay. Then 4, 1. Then we're going to have 4, 3. And that would have all the edges that we need. Okay, any question with this so far? So I'm going to go ahead and label this vertices. And then we're going to have edges. Okay, so for number 1, we would start out with just manually identify this, the graph that's given to you. We would identify the vertices and the edges in that graph. And it is an undirected graph. So it's a simple graph, right? Then in the next part, we would then create adjacency lists. So for this, I'm fine with you filling out the matrices. So if you wanted to list them all, that could be, you can do like adjacent. Okay, just like what we've done before in the assignment. So we can say 0 is adjacent to 1 and 4, right? And then 1 is adjacent to 4, 3, and 2, and so on. 2 is adjacent to, that will be, sorry, let me scoot this up. Let me scoot this up a little bit. So we would say that 2 is adjacent to 1 and 3. And then 3 is adjacent to 1 and 2 and 4. Okay. And then lastly, we would have 4 is adjacent to, we would have 4 is adjacent to 0, 1, and 3. Then next we are going to create the vertex, the matrix using the vertex. So 0 to 1, since we have the adjacency list here, you can use that or you can refer to the graph. 1 to 1, we're going to put a 0. Okay, and I use a table. You're welcome to use the matrix symbol. That's fine. The bracket is fine. 1 to 2, yes. 1 to 3, yes. And 1 to 4, yes. Okay, since we have that. And then 2 to 0, no, right? 2 to 1, yes. 2 to 2, no. 2 to 3, yes. And 2 to 4, no. Then we move over to 3. 3, we have 3 to 0, no. 3 to 1, yes. 3 to 2, yes. 3 to 3, no. And 3 to 4, yes. Then for 4 to 0, we listed that earlier, so yes. 4 to 1, yes. 4 to 2, no. 4 to 3, yes. And 4 to 4, no. Okay. So this gives us a better understanding about our graph. Any question? So for A, B, and C, we simply just manually identify the edge, the vertex, the adjacency, and build out our matrix. Then we then go into the programming side. And in this one, you are going to use vector. And I know that you might have covered vector in some of your programming courses like CIS5, maybe not, it might not even get there, or CIS17A and C. Let me double check, hold on one second. Yes, sorry. I'm missing that one. 1 to 0. Thank you for pointing that out. Okay. Any question before we move to vector? So if you're not familiar with vector, vector is a container, and unlike array, vector can grow and shrink. And we would then use vector STL to be able to use some of the methods, okay, or functions, built-in functions. So a way that we can add an element to our container, which is a vector, we can do a pushback, okay? And with pushback, it's going to add the element next to the current last element. So let's say that if I have 1, 2, 3, 4, 5, and I'm trying to push in a value after 5, I can do a pushback and it's going to add that value after 5. Okay, so it will be then become the last element in that container. And here it says the value content is copied or moved to the new element. So then the last index would become the element that you just push into the vector. Then as you push into that vector, as you add that element by doing pushback, the container itself is growing by 1 element. So then we can increase the container size by 1. So it automatically adjusts the size by that 1. So this really implies that it automatically reallocate the allocated storage space if and only if the new vector size surpasses the current vector capacity. So still, it actually has a specific capacity, right? And as you keep pushing in the element and as it grows, and when it reaches that capacity, what it does is then it can extend and reallocate the size to make sure that it holds all your elements. So compared to array, and even when we're, very similar to what we see with dynamic array, is that it is flexible in that the number of elements that's going to be, it's going to adjust the size to the number of elements. And when we use pushback, method or function, what we see is that we would then can only add the element into our container as a last element. Okay. And this is what you would often see when people would refer to something like the stack. So the last thing that's going to come in is going to be that last index, the last element index. Okay. And we can do a pop. When it pops in the vector, it's going to go to that last element and it's going to remove it. So it's the last thing that comes in is going to be the first one that's going to go out, very similar to the stack structure. Okay. So in our program, let me open it up on REPL here. Now you can definitely use vector for your project. Okay. And I don't require specific container as long as you deem that it will be fitting for your project. I'm fine with that. So in this program, we would have include IO stream for C in, C out. We would then have vector STL include, so that way we can implement the function from that STL. So because we're not returning from the function, we would then use void. And here we have a function that we customize, we create. So we define that here. We are going to use this function to add the edge. And in the parameter, since you're using a container, very much like the array, you would then pass it. But with vector, you would have to include the type. So here we would say that that will be integer. Then we would have another container that would be called adj, which is an array. And in this, that's going to represent our adjacency. And then we would have a variable for our vertex. Okay. So then we would then add in. And so when you run this, what you would see is you would see the representation of how the vertex are connecting. And what we can do is we build out the container that's going to be able to draw the edge. And we have another container that's going to be showing the adjacency, who's adjacent to who. And then we would have variables that's going to represent our vertices. Okay, so then in the void, the add edge function, we would use, right, the adjacency to add in the elements so that way it would draw it out for us as a graph, like who's connected to who with an edge. So basically we write a function to be able to draw the edges. So here, as it evaluates the vertex for adjacency, okay, it's going to then be able to put that. So if it's adjacent, it's going to draw the edge. If it's not adjacent, then it's not going to draw the edge. Okay. Now, can you get away with this by doing two-dimensional array? Sure you can, right? Then when you print it, you still have to loop it so that way it would print. So in the second function, so the first function allows us to draw the edge. The second function allows us to really print it, right? Because in C++, if we're not designing graphical user interface, if we don't have the UI, we would just have to represent it as text. So we have to output the graph itself as text. So here we have another function called print graph. And again, in its parameter, we wanted to use the container. Okay. And in this function, we would have the first for loop that's going to give us, that's going to print out the vector like 1, 2, 3, 4. So we would then see our vertices and the adjacency for our vertices. So here it's going to give you the adjacency in the first for loop. And then in the second for loop, it's going to give you the actual vertex because it's pulling that from the adjacency container. Then in the main, we simply put in, we declare, right, what is the variable v, how many vertices. So the capital V here represent the number of vertices that we have. And then we would then specify how we want to use our vector and our adjacency with the V. So what it's going to do is going to evaluate, right? When you do it this way with a V as a variable here, you can specify the number of that, just like how you've done it with the array. You have to give it a number of elements for that container. Then we hard code in, right, the function call here, but we hard code in the actual vertex, which one is adjacent. And then we call on the print graph function. And in that parameter, we simply pass adjacency and big V. And big V allow us to really loop through and get through the 5. Okay. So once you have that input into your IDE and run the program, we wanted to look at the first part of the exercise 1 to see if it actually matched what we were trying to represent. Okay, so going back to the beginning, we wanted to check to see if the adjacency is correct and then how it built out that particular graph. So when you look at that, you say, okay, so 1 is to head is going to be, so adjacency list of the vertex 0. So we start at 0, 0 to 1, and 0 to 4. Okay, so let's verify that real quick. 0 to 1 and 0 to 4. Okay, so that's correct. And then what we have is then we would go back and we would verify 1 to 0, 2, 3, and 4, right? So if we look at our adjacency list, 1 is 0, 2, 3, and 4. So that's verified. Okay. So in this program, what we're doing is we are using vector STL. We have 2 functions. One function that's going to draw the edge connecting the adjacent vertices to the edge, which is represented as this. Okay. And how I use auto here, right? This is gonna be like a for range loop. So that way I don't have to add in the three parts that what you see in a regular for loop like this. Okay. So we have the little arrow as in the C out, and it's gonna go through every single vertex and it's gonna fill that in for me as long as the vertex is adjacent. Okay. Along with that, we wanted to show the adjacency list by illustrating this. So this is a way that you can show which vertex is adjacent, right? Simply using multiple container. One is a vector and one is an array, and a few variables and a couple of loops. So two functions, not too complex of a program. Okay. Any question? So in number one, after we fill out the answer for the question A, B, and C, we would then build our program. So we wanted to verify if it's matching the exercise. If it's verified, you can just answer yes. And I want you to look at the program, look at the function, and identify the section of the code that produces the adjacency list, which we talk about the function were to print adjacency lists for the graph. And the other function allows us to add the edge or draw the edge. So give me a brief explanation on the functionality of the program in the area of building the adjacency list and showing the overall graph. Okay, and we talked about those functions already. Then for question G, it asks you to take a look at the graph and simply answer the question, can a programmer create a C++ program for a graph without evaluating adjacency of vertices? No, right? Because if it's not adjacent, you cannot draw the edge, and so therefore you cannot illustrate it. So in this, I like to use this opportunity to really show you how to use vector if you're not familiar with that. And this is very light, right? Vector is a lot more than this. So it kind of introduces you to how to use pushback with vector. And then how to really build out a program for graph. Any question? Let me know if you have questions, okay? Okay. All right. Next, If you're finished with this, then we can go on to the data structure one. And on, yes, questions? So Rashad asks for question F, when it talks about producing adjacency list, is it asking the function that creates the list or displaying the list? Both. Because you have to be able to create it in order to uh, print it out, right? Okay. Any other questions with exercise 1? So in the next one, we are going to talk about struct. And so it starts with giving you the definition of struct or data structure. So a data structure is a group of data elements that's grouped together under one name. So we basically create an identifier with the type struct, and the data elements are known as members and can have different types and different lengths. So what do they mean by that? Well, when you define a struct, you would then say struct, and then you would put in the name. And in that, what it does is it's going to group the member subsequently together, even though they have different data type. So something like you might have int and double, or you might have int and float, etc. It depends on what you're trying to do with your program, right? So then the example that's shown here is that you would see, I'm going to enlarge it a little bigger. You would see a struct called product, and then you have int weight and then double price. Maybe we are making a program to calculate the price for the pound of fruits or produce for a supermarket, maybe, right? So since you declare, right, your struct here, then you can use it, right, for specific objects. So then your object name can be set of valid identifiers for the objects that can have the type of the structure. So basically, once you declare your struct, you will be able to access its member for other objects. Okay. Like I wanted to be able to calculate, or I wanted to be able to access weight and price for apple or banana or melon. So when we declare the structure type called product, so it is a type and having two members, your weight and your price. So inside the curly brace, those are going to be your members. You can have more, right? You might have 6, 7, 10, etc. So what you can do is you can group them together because they're a different type. You can group them together under the type that's declared. So when you say struct product, product becomes that the data structure type. Okay. So here it gives you a little bit of an example there. And so after you include your members, you would then enclose your curly brace and then finish it out with the semicolon. and then you'll be able to use the type. So with that gives you like a brief intro into what we will be doing. And then we also have class. And class, right? If you've taken classes that cover class in Python, Java, C++, same. Okay. So this is a way for us to specify a form of an object that it combines data representation and methods for manipulating that data into one neat package. So what we're doing, we can define a class, and inside that class, we would have function, member function, or in Python, that would be member method. We would have variables or container that would store data. So it would be member variable or member array and so on. And so we would start with the keyword called class, and you can see that in this example here. So in this one, we declare a class box, right? And it's a good practice to use capital letter when you are declaring your class. So you would say class box. And this is a public class. And that is just gonna be able to, that means that it's accessible to other classes, right? We can also make private and protected classes. And if you're familiar with my Java or took my Java class, right? Java, that's the first thing that you start with, is understanding class and object. Okay. So similarly, you would say whether the class is private or public. And then inside that, you would then declare your members. Okay. So we would have member variable like length, breadth, and height, because we might even have a function that will be allowing us to calculate the dimension of the box. So then in the class body, that will be inside your curly brace here. And we would then, similar to the struct, we would follow it up. After we enclose the curly brace, we would follow it up with a semicolon. And the keyword public here, that is just your access attributes, like I said. So that means that the member variables inside here is accessible to the public. Okay. Now you can have private and protected and default, where private, the members will not be accessible to other classes. And that could be for security reasons. And you can build classes into a program, right, for all kinds of things. And it's also helped us in organization, in how we structure our data, and we structure the program itself. Okay. Now, I don't expect you to use class in your final project, but if you do, it's great, because if you have the knowledge to apply your skill sets with programming, that's a plus. Okay. But in the upper division programming classes, they expect you to be able to use classes, objects, right? And so on. Okay. Any question? Okay, so let's take a look at this graph now. And similar to what we've seen before, you have these two that are isolated from the rest. And this is a directed simple graph. Okay, so first we would start just like the other one with vertices. And so this is easy, 0, 1, 2, 3, 4, and 5. And then in the next one, we have to look at the edges. Okay. So we would say edge. We have 0 to 1. And then we have 1 to 2. And then we have 2 to 1 and 2 to 0. And we have 3 to 2. And we have 4 to 5 and 5 to 4. Okay. So for A, we simply just list your vertices and the edges. Then we would move on to the next one where we would list the adjacency. So we can start with 0. To 1 and to 2. And then 1 is adjacent to 0, 2. And then 2 is adjacent to 0 and 1 and 3. And then 3 is adjacent to 2 and only 2 because it's only 1 degree. And 4 is adjacent to 5 as 5 is adjacent to 4. Okay. Any question? So after we establish our adjacency list, then we would need to move on and build our vertex matrix. So 0 to 0 is 0, 0 to 1 is 1, 0 to 2 is 1, 0 to 3 is none, 4 is none, 5 is none. Then 1 to 0 is 1, 1 to 1 is 0, 1 to 2 is 1, 3 is none, 1 to 4 and 5 is none. Then next we are going to do 2. 2 to 0 is 1. 2 to 1 is 1. 2 to 2 is none. 2 to 3 is 1. 4 is none. 2 to 5 is none. Then 3 is not adjacent to 0. It is not adjacent to 1. It's adjacent to 2. And the rest is 0. Then for 4, 4 is adjacent to nobody else except for 5. Same thing with 5. 5 is adjacent to 4 and not to itself. So in planning out your program for graphs, we would start with, right, just the visual identification of graph components like vertices, edge, adjacency, and then we build out our matrix. Okay. Any question? Okay, good. All right. So this is just what we have gone through in the lecture as well, right? I'm sorry, my internet is unstable. So if I one of my, okay. All right. So now let's take a look at our example program in C++. And in this one, I didn't do a screenshot because it's longer. So you can copy and paste it into your IDE. However, be careful with the symbol because Word doesn't translate well to other text editor. Okay, so if you run into errors, check your like semicolon, quotation marks, curly braces. Even though it's there, you might have to retype some of those just to, so look at your error message, what it's telling you, and if it's saying that it's missing, semicolon or whatever, then just retype the symbol. And that's my experience with the students when they copy and paste things over into IDE or text editor. Okay. Most text editor translate okay, but some doesn't do well, especially some online ones. Yep, Jacob is right. Quotation marks from Word into IDE, definitely. Quotation marks, semicolons, stuff like that. So, all right. What I'm going to do is I'm going to pull up this program. We don't have to do too much today, so we can just kind of take our time a little bit. Yep, that is right. It's encoded differently, that's why. You can turn them off in Word. Thank you, Eric, for pointing that out. Okay. So in this one, you see the stuff that we talked about, struct, class, right? That's why I put the details there, so that way if you're not familiar with it, you can at least read the information about it, look at the example, so you kind of look, when you look at your code, you would know what that is. Okay. And when you look at more of an advanced program, like for CIS 17C, or some of the upper classes, you would see it, the expectation is that by that point you should be able to write program that has structure, right? That has classes, that has objects, that has pointer, and so on. Okay. So, um, so when you look at example online, for example, when you're looking at like binary trees program, doubly linked list program, things like that, for that would entail or relate to data structure, you would see, right, classes, nodes, struct, etc., like this. Okay, so in the first part here, we would have data structure to store adjacency nodes. Okay, and we use next. So when you declare struct node here, you made it into a type which can be used, right, with objects. And then in the second struct, we have it as used for edge. So this one is now become the type. And in the node, we have a variable called int_val. And in struct edge, we have src for source, how it starts, and dest for destination. Then following those, what we have is, so what happens is this is a variable, which is a member variable, and these two are member variable of that type. All right, then in the next part, you have class graph, right? And here is where we would then utilize what we had started with the struct node to be able to build out our adjacency list. Okay. So now we have a function that's under a node, right? That's going to be using the member variable from both to be able to draw out, right, or build out your adjacency list. So here we construct the object new node, and that object is going to be tying the value, which is represented with numbers, because remember we have to draw that directed graph, and then we are going to be able to point it to where it's going to connect to, because that's going to represent how the two vertices are going to be next to each other. Okay, here is where we're going to point. Okay, so again, we are going to use that object to be able to point to our next as the same, as equal to, it is head. Okay, so in the next one, the adjacency list, it's gonna have the vertex, its adjacent neighbor, and then from there, because it's directed, it's gonna then move over to the adjacent neighbor becoming the head, and then so on and so on. So it's gonna build out your adjacency list. The int n here is just gonna be the number of nodes or vertex in the graph. So in the class, right, we're gonna point to the location that's going to store our head information because it's updating every time. Okay, you see how it updates here? So we need to be able to point back to it and say that, okay, on the next vertex now become the head, and so on. So with this, what we would do is we would use pointers to the node to represent the adjacency list, which we build out here. Then we would then also have an additional constructor. So as you declare that class, you would use that class to construct object. Okay. And in that, we would then reference the struct edge that we declared earlier to, as that would be the type, and then edges array to hold the edge information. Okay. And in this one, it uses the keyword this. So you're gonna have end to end. N is n. And here we also construct. We have a constructor which simply set up the memory location for that array. After that, we would have a for loop, and in this loop, it's gonna be able to loop through and point to all the vertices because they are individual entity, right? And we point to them. So here is where we have to loop through, and we would use the null pointer here. Then in the next for loop, we would then loop it so that way we would be able to add the edges. Now we're going to actually draw the edges from one point to the next. Okay. As we use container and the container is being pointed to, right, for the element in the indices in that container, then we would have to set all of that up here and then be able to use the for loop to access the indices in that array for your edges. Then for here, as you can see in the comment, we are going to then use the function that we previously had declared. Then we are going to also point to the object, pass the destination and the source. So it's going to then insert it, each of the head every time. Okay. So that's going to be this section right here. Now, if you uncomment, you would get an undirected graph. But if you leave commented, then it will be a directed graph. And in C++, when you construct object, right, it doesn't go away. So you want to free up the allocation. So we would then use delete to, it doesn't do garbage collection very well. So we would use delete to remove the object that we constructed. Okay. So we deconstruct it at that point. Now, it's a good practice to do that. In Java and other languages, it's better because it does a better job at garbage collection. So you can do it in the other languages as well, but it's not necessary. It would just be like a few lines, but you know, you can use that to do something else or and so on. But in C++, it's good to clean it up. Okay. Then we would have a function to print, very similar to the other one. And in this one, we would have a while loop. while PTR is not null pointer, we would print, right, the arrow, and then we would point to the value, which is 0, 1, 2, 3, 4, 5, etc., right? And then that will be our output piece. Now in the main you have an array, so you have to declare the edges, right? And we had a type edge. That's the whole point in using that. So using the struct edge earlier. So you have an array that's going to hold the edges. And just like how we type it out earlier, we wanted to assign the edge values here in that array. Okay. And then the big N is going to be your vertices. And to calculate the edge for the little n, you've seen this before in the other programs. So when we use array and we pass n, we just need to be able to tell it how it's going to be able to achieve that n or half that n. So we would have size of the edges, which is the number of elements in the edge array, right? Divided by side of edges index, the first element, index 0. Then we construct the graph, and we have the class graph. So here is where we would pass edges n and big N. So that way it will build out the graph. And for the next for loop, the last for loop in the program, that's going to give us the adjacency list as it's going to loop through, and it's going to print out your index. And we're going to call on the print function. So when we make this, you have it drawn, right? 0 to 1, 1, 1 to 2, 2 to 1, 1 to 0, 3 to 2, 4 to 5, 5 to 4. So you tell yourself all of that just to get a few lines output, sure. But in this one, definitely more advanced than the other one that you saw, in that it uses data structure, it uses class, uses pointer. There's organization in how we store data in this particular program compared to the earlier program. Okay. All right. So you put that into your IDE, and you run the program, and you look at the output. Is it giving you the correct thing, like what you've seen, what you listed earlier in exercise 2 for A, B, and C? Compare the program adjacency list to your result for exercise 2B questions. If it's matching, you can say it's matching. If it's not matching, say it's not matching. And hopefully you can understand why, right? By now you should. And just like the other one, can you build a program without knowing the adjacency list? Not really, right? We hard code in the edge information if you look. And without that, you would not be able to have this. Well, other areas too, but okay. And then compared to the simple graph program in exercise 1, right? And to 2, what areas of the program produce edge directions? Like for the directed graph, explain the code functionality for the overall program. So go back to the program, okay? And then look at the section where, starting with this part right here, okay? On how it's able to draw the edges in the direction. Remember down here when you uncomment it, it would give you the undirected graph. So this part. And do your best. I know some of you haven't taken advanced programming classes. That's okay. Right? Okay. All right. Any question with 2? Unlike the other ones, we have 3 only today, right? So, because the last 2 are kind of long. Okay, so for the next one, we are going to use the same graph, but in this one, it's weighted, right? You see the little numbers next to the edge? These are weighted directed graph, right? This one. So we would start with 3A by identifying the vertices, just like the other one. And that's easy. I want to just highlight it so you see the answer easier. Okay. All right. Then we would do the edge. Okay. So 0 to 1. We have 1 to 2. Very similar to the other one, right? So you can take the earlier answer and put it down here if you wish. Same. The main difference is going to be what? Your matrix. So I'm going to put here same as 2A. Now on the, when we create the matrix, instead of using 1 when it's adjacent, we would then have to use the weight, right? So for the adjacency list, you can also put, you can copy and paste it from earlier, but I'm going to put the same as exercise 2B, right? Okay, then we would then make our matrix. 0 to 0 is 0. Okay, 0 to 1, the weight for that is 6. You see the 6. 0 to 2 is going to be none because it's directed. Okay, so we have 2 to 0. Then 0 to 3 is none. 0 to 4 is none. 0 to 5 is none. 1 to 0 is none. 1 to 1 is none. 1 to 2 is 7. 1 to 3 is none. 1 to 4 is none. 1 to 5 is none. Then I think I made a boo-boo on the top here. 1 second. Let me come back to 2. Yeah, and this one is only going to be 1. 0 to 1. And then 0 to 2 is none. Because it's directed, you're going to go where the arrow is pointed. Okay, so you figured that out? Okay. So on this one, just like number 2, because I had it listed a little, that was wrong earlier. But so we go 0 to 1, right? Is going to be 6. Okay. And then for 2, 2 to 0 is 5. So Sarah, that's right. And then 0 to 1 is going to be 4. And then 2 to 2 is 0. 2 to 3 is 0 because the arrow is going to be 3 to 2, right? And then 2 to 4 is 0. 2 to 5 is 0. And then for 3, 3 to 0 is none. 3 to 1 is none. 3 to 2 is going to be 10. And then 3 to 3 is none. 3 to 4 is none, and 3 to 5 is none. Four to 0, nothing. 4 to 1, nothing. 4 to 2, nothing. 3, nothing. 4 to 4, nothing. And 4 to 5 is going to be 3. 5 to 0 is going to be nothing. Nothing, nothing, nothing there. And 5 to 4 is 1. Okay. Any question? Let's leave it there for a little bit while some of you are finishing. Yeah, because it's directed, we can't do 0 to 2. Even though there's an edge to it. So if it's undirected, if it's not directed, then yes, that will be, you would include it. But since it's directed, it can only flow from 2 to 0. So we can't claim the edge from source to destination. Okay. All right. So in the directed graph, the takeaway is that, while it is an edge, you have to see which one is the source and which one is the destination, and that would be the valid indication whether they're adjacent. So again, this one is very similar to the other one. The only thing that's added in this program, okay, is the weight, is the third, the W, the third parameter here. So let's take a look at it. So it's almost identical, like I said, right? As the earlier program, you have the struct node, the edge, so those become the type. Then you got class graph inside it. You wanted to build out adjacency lists. Then you also build out how you draw, but importantly, this right here is that you have weight now is in consideration because it's weighted graph, and you also have the weight parameter when it inserts. Okay. And then down here, when we assign values for our vertex, right, and our adjacency, we would then have the third parameter that's going to be our weight. Okay. So in this one, it's just going to tell you 0 to 1, that's a 6, weighted 6, 1 to 2, weighted 7, and so on and so on. As the output. And people built libraries and tools for graphs. Why not use it like GraphViz, right? But I want to show you how that would be in C++. And, you know, and these programs would be adequate in that we have, you know, structure in the program, we have organization for our data and how we allocate the data, and so on and so on. But if you wanted the visual image, use external tools, packages. Okay. So put the program into your IDE, run it. Okay. And then when you look at the adjacency list, right, is it matching up? And compare that in exercise 2, when you have an unweighted directed graph, what areas of exercise 3 program produce the weighted edge? I mentioned that already, right? And you can briefly point out, like in the main, it's this, and then in the class, this is the area, and this is what it does. And then to your best knowledge, explain the functionality of the code in the overall program. Now, this is not the only way to represent this, right? You know that. There are other ways to approach this problem and be able to build out your graphs as you've seen in exercise 1. And then there are other ways. So you can use container differently. You can have, you know, different functions and so on. But the overall approach, what we see is that we first have to establish the adjacency list, just like how we would manually do it when we visually doing it with, you know, earlier. We gotta list the vertex, we gotta list the edges, right? And then from there, it's gonna be able to connect those two together. Okay. And I tell my students all the time, we human designed a computer to be like us, right? So how you approach it is how you would then program the computer to approach it. Okay. All right. Wow, still very early. Do you have any question for me? Okay. I'll stick around for a little bit in case you have questions, concerns, even not related to the lab, like for a project or something like that. Um, as before we take off and sign off, I want to mention to you that very similar to my CIS11 class, we will eventually finish out all our content, okay? And I will give you lab days to work on your project in the upcoming weeks, okay? So we do have, let me take you to the unit so you can see. In the other class, I finished a little sooner, but we still have in the next one, I wanted to touch on cryptography, and this could be pretty fun, where we would learn how to program Caesar cipher, which is the substitution encryption. It does a alphabet shift, and so that kind of give you a taste of what that would be like, because Caesar cipher is one dimension. It's shifting horizontally, but in Vigenère, it's two dimension that it shifts horizontally and vertically, and I will explain that. So we will touch on chapter 5, where we will touch on cryptography and a little bit of modular arithmetic using mod. Um, you know, it's a little bit of math there. And then we will have relations. And for the relations, I'm going to have a discussion post for automata, and an assignment for your quiz review in week 12. Okay, so instead of a lab, you can just post a discussion. So starting from week 12, you are not required to show up on Wednesday. I will be available for, like, from 6 to whatever. I'll turn on my Zoom and I'll be here in case you wanted to pop in and ask questions. If you're not clear on something or you have some concern about your project, if you can't come to my office hours. I realize that my office hours throughout the day, because I teach at night, every night. Um, so it might not work for everyone. So if you want to, pop in, so I would likely be on from 6 to 7 ish, 7:30. I'll turn on my Zoom, I'll stay, and and if you can't make it earlier, like 6, if you wanted to stop by a little bit later because you get off work late or something like that, that's fine. Okay. Or if you want to need to make an appointment to see me outside of my office hours, I can. My schedule sometimes does get a little intense, but I'll make time for students. So I will tell you when I'm available and if that works with you. If not, we can schedule it for the following week. And it changes for me week to week as, I have different meetings and obligations and so on with the college. Okay, so we have one more lab to do for next week, and then we will have assignments in week 12, um, and then discussion, and then I will open up the final review. So does that mean that you're not gonna come to class on Zoom anymore? So after week 12, in week 13 on Monday, I like to cover for 2 consecutive weeks. Every Monday, I'm going to try to cover final review. I will go through every questions that's going to give us the whole refresher in what we covered, because I understand you have tons of other stuff to worry about too, and sometimes you forget. But if you want, if it's not mandatory. Final review session is up to you. So if you wanted to attend, starting at 6, I will go through each of the questions. There are 2 parts. So week 13, part 1 on Monday. Week 14, part 2 on Monday. I will give you week 15 off. That's traditionally what happens. And then week 16, you turn in your project and you take your final, and we say farewell, and we will enjoy our summer. And hopefully I'll be able to see some of you in my credit and non-credit classes. I'm doing some fun non-credit classes, short session, 2 weeks this summer along with cyber camp. So yeah, um, that will wrap up our whole entire semester. But don't wait till the last minute to work on your project. Keep in mind. And then likely I will be able to share with you some example for projects. So you can take a look at it later. But I want you to at least look at it first, attempt it, and then instead of looking at other student solutions and so on. All right. Okay. Type your name into the chat. Thank you very much for attending the session. I appreciate your time. Have a wonderful evening. I'll see you next week on Monday. Take care.